Good morning. It's a pleasure to welcome you to the second day of the National Conference on Large-Scale Integration of Renewable Energy, organized under the GTG RISE initiative, the central component of Greening the Grid or GTG program, a joint initiative of USAID and Ministry of Power. As an introduction, I'm Monalizia Hazra, Regional Energy Manager and Clean Energy Specialist at USAID India. India has adopted a low carbon path to meet its growing power demand. The focus on expanding India's RE capacity, targeted to reach 175 gigawatt by 2022 and 450 gigawatt by 2030, represents an immense economic and environmental opportunity. But it also brings challenges to grid stability. Today, we will be discussing two very relevant themes that will dig deep into two key strategies for increased flexibility in the system. The first session focuses on flexible operation of coal-based power plant, and the second on the automatic generation control as an enabler for secondary reserves market. This will be followed by a high-powered panel discussion with key interlocutors in the valedictory session. Panel will discuss the roadmap ahead, keeping in perspective what has been done and what more needs to be done from policy, regulatory, and technology aspects. We wrap the conference up with a side event on the role of private sector as an enabler to the large-scale integration in a side event in the evening today. So an exciting day ahead, and I do not want to delay it any further. Let's kickstart the first session today, which is on flexible power generation, facilitating renewable energy. So as we've been discussing, responsiveness and operational flexibility of conventional power station is important to support grid reliability and stability. Ministry of Power and CEA have taken cognizance of this imperative and set an agenda for thermal units to operate in tandem with RE generation. This session will deliberate upon the milestones achieved, challenges and scalability opportunities for flexible operation of coal. We begin with a short context setting presentation on the learnings from the pilot undertaken as a part of USAID's GTG RISE initiative, which will be followed by a panel discussion. So without further ado, let me first introduce our presenter for this session, Mr. Anuj Vasishtha. Anuj is the energy sector consultant with more than 15 years of professional experience in power generation, transmission, and distribution. He is the director in the energy and utility practices at Deloitte. Prior to consulting, he has worked in coal and gas plant. Anuj was also the pilot manager of the flexible power generation pilot at the USA GTG RISE initiative. It gives me great pleasure to invite Anuj to make the context setting presentation. So over to you, Anuj.
Thank you, Monali. Good morning, everyone who have joined the second day of the National Conference on Large-Scale RE Integration. We have a host of distinguished speakers on the panel to discuss on this interesting topic. But before the panel discussion, we have a short success story of the pilot study that we have done over the last 4 years with the central and the state generating utilities. So quickly taking you through that pilot case study. So this pilot study was actually done with NTPC on two of its units, one at Jhajjar, which is a 500 megawatt unit, and one 200 megawatt unit at Ramagundam. And similarly, two units of the State Utility of Gujarat State Electricity Corporation Limited, both 200 and 500 megawatt coal-based units were picked. And thanks to all the plant officials for providing us the support and coordination for that. The study was also would not have been possible without the support of Mr. A.K. Sinha, who was our technical advisor on this project. And he was one who actually steered the pilot with the entire team of GTG Rise, and was very instrumental in providing technical inputs at various stages of the pilot. And equally important was the support that was garnered to us by our technical partners from Intertech, the team led by Mr. Nikhil Kumar, who is also on the panel today, and Mr. Douglas Hillerman, and this whole set of team of experts from Intertech. So that was the team which did the entire damage cost modeling exercise for the pilot study. So fantastic piece of work that was done over the last 4 years, and quickly taking you through that journey. The genesis of this particular study came out in one of the reports that was done by National Renewable Energy Laboratory, NREL USA. This was a grid integration study that was done at a national level as well as a regional level. Study was done by NREL in partnership with POSOCO and LBNL. And the study very clearly emphasized on the aspect of having flexible generation for conventional plants across the country. And the reason why it pointed out very strategically was to ensure that minimum RE curtailment takes place when we actually are looking at a 175 gigawatt or a 450 gigawatt of RE capacity as it stands today. So the study clearly laid out that if the coal-based plants are actually running at 70% technical minimum, and with a 175 gigawatt scenario in 2022, an RE curtailment of close to 3.76% would be envisaged. And this, if it is brought down, if the technical minimum of the coal units is brought down to 40%, then the RE curtailment reduces significantly to 0.76%. So this was a huge number that we were looking at. And this actually helped us identify the problem statement that the way the plants have been run throughout the past would essentially require a huge change management in terms of the operational practices, and the absence of flexibility in the coal power plant operations poses a significant risk if it is not tackled and if it is not made adaptive in the near future. Secondly, we also realize, and this came from the inputs that we received from international experts, is that operational effectiveness is not just self-sufficient. We would also require a host of other aspects to look at, essentially to build a roadmap for a sustainable development of flexible operations in the future. So with that problem statements in mind, we identified the objectives. One of the key objectives was to look at whether how the technical and commercial feasibility of the units needs to be carried out for faster ramp up and ramp down. Also, we will have to look at the various measures and interventions, including changes to the operation procedures if there are some units that would require retrofits, and essentially the cost of bringing those interventions to be adapted. And then we will have to look at the compensation requirements, because all this comes at a cost. What are the incentives or the compensation that should be made available to the plant generators? Provide some demonstration tests to build in confidence to the plant operators, and also look at strategizing on the fleet-wide operations for these two utilities. So based on that, we also outline the specific outcomes. We would look at specific recommendations to change of operational practices and procedures, identify which all minimum retrofits would be required, look at the incremental cost of generation due to cyclic operations. This is something which was very new. There was no study so far conducted at that point of time. Also look at what all regulatory and policy advocacy requirements should be in place as enablers to ensure a smoother transition to flexible generation. And last but not the least, how to look at scaling up these initiatives So as these demonstrations pilot are actually taken up at a fleet-wide level by the various utilities. So as I mentioned, we started off way back in 2017, and the initial period was essentially to look at the way the units have been run for the past 10 years. And this involved a lot of data assimilation and data analysis, which was done by GTG Rise with support from the Intertech team. We actually looked at 10-year data for each of these units from NTPC and GSECL. And when we looked at the data, this essentially was not just the operational data. We also looked at the way the units have run, the various breakdowns that have taken place, the forced outages, the auto run-up cycles that have been followed, the costs that have been incurred for major overhauls, the water chemistry that was followed during this entire course of last 10 years. So all this was mapped, for a damage cost modeling exercise by Intertech, and this essentially gave us an idea of whether the units would be able to adapt to flexible operations given the design, the make of the unit, as well as the useful remaining life, and also at what cost, what cost would be attributable for running these units on flexible operations. Going forward, we looked at once we had the damage cost modeling exercise done, we started preparing the incremental cost of generation, because that was one of the outcomes that was there. And meanwhile, when we did this entire set of site-specific studies, we interviewed the various officials of these units of various departments to look at how they have conducted the practices in the past. We also did knowledge dissemination workshops. There were executive exchanges to the US, which essentially helped the officials from NTPC and GSECL and others to look at how utilities in US have adopted those practices with minimal change to the equipments, with minimal capital expenditure that has been incurred on the units, just by sheer change in the way the units have run, the operational practices, changes to the operational practices, they have been able to adapt to flexible operations. So having done that, we also moved on to preparing regulatory consultation papers. We presented the compensation mechanism and the incremental cost of generation that we analyzed would be attributed because of flexible operations to a 200 megawatt and a 500 megawatt units. The papers were presented to both the central regulator as well as to the State Electricity Regulatory Commission of Gujarat. We still understand that these are being considered given the fact that that more number of units are getting susceptible to flexible operations. And having done that, then we actually came out with the demonstrations test for the various pilot test runs. We did that in Gujarat. A successful 40% pilot test run was conducted in Gujarat as well as in and hello. And then of course we as a scale up to the pilots that we did with NTPC and Gujarat, we also looked at providing support to one of the other state utilities in Karnataka, and we looked at again a 200 and a 500 megawatt unit at Bellary and Raichur units at Karnataka. And as we speak, we are made to know that they are looking forward to conducting a 40% low load test run in one of their units based on the operational procedures that we have shared with them. So some of the key recommendations, and in fact these were the various impacts that we created during the pilot. Of course, the operational practices need to be changed, because most of the coal-based plants units were run on base load till the time we actually started this study. And this essentially required a sea change in the operational practices. Typically, when you actually bring a unit down during shutdown, there is a ramp down rate, but the procedure that is followed is slightly different from the way you want to run the unit on at 40% or let's say 30%. So this essentially requires changes to the operational practices. As I mentioned, we looked at the operational practices for the past 10 years. That gave us significant amount of learning on how the units should have been run, and going forward, if going in the near future, if the units are required to run on flexible operations, what all changes to those procedures are required. And of course, demonstration test essentially helped in identifying what all changes to the operation practices should be adopted by the plant operators for ensuring that low load test runs can happen gradually and frequently in the near future. The second and a key important recommendation that came out was on benchmarking prioritization. There's a host of fleet of coal-based units. For example, for NTPC, almost 90% of their units are coal-based, and this is not only NTPC but for the rest of the state utilities in the country. It became imperative to bring out a roadmap as to which units would be made susceptible for flexible operations, which units should be taken up based on what parameters should they be selected for flexible operations, and how they should be made use to the recommendations that have come out under this particular study, whether they can utilize those for ensuring changes to their operational guidelines or making retrofits to their equipment to ensure a quicker adaptation to flexible operations. The third and important takeaway from this from this pilot study was on the low load ramp test procedures. This essentially was developed with collaboration with BHEL, and based on this particular document, we were able to successfully conduct 40% minimum low load test at GSECL UKI unit. This is a publicly available document. This was released last year, and it is now available for all the utilities to download and for information. This is available on the GTG website. The fourth and most important component of the recommendations that came out was on compensation. As of now, as we understand, the IEGC regulations provide compensation up to 55% technical minimum, and this essentially was an exercise to present to the regulators as well as to the utilities that what would be the incremental cost of generation because of degradation in the heat rate, because of increased specific fuel oil consumption, because of the equivalent forced outage units, forced outage rate of the units, and also because of the various environmental concerns. So for the degradation of the heat rate, for every 10% reduction in the technical minimum, what would be the incremental cost of generation is something which the study came out with. And this was essentially captured by CEA in its report on the roadmap to flexible operations in 2019. And it's a publicly available document now for all to see. The capacity building of operators was essentially one of the critical success factors. We were able to capacitate and train more than 500 engineers, and throughout the study, we were able to conduct various knowledge dissemination workshops and webinars on providing the inputs that we had learned, bring in more international experts, bring in the stakeholders, including the Central Electricity Authority, POSOCO, CERC, Ministry of Power, and various other utilities, state utilities, and for imparting knowledge dissemination workshops. And last but not the least, the scalability component is something that we did successfully with KPCL, but we would also like to point out that there is huge potential of scaling this particular exercise of flexible operations in the country. And this is also eminent from the CEA's report that has came out. Close to 82 gigawatts of flexibility of capacity can be made flexible for 175 gigawatt of absorption. These are some of the key indicators that we discussed. Some of the reports that were released. I mentioned about the minimum low load ramp test procedures. There is a summary report that has been publicly released last year. This talks about the entire journey of this pilot in much greater detail. And of course, there is a fantastic recipe book for flexibilization of coal-based power plants. This is a very comprehensive book. And this essentially talks about the various technical elements on the damage cost modeling studies, on the various checks and balances that needs to be ensured when you are actually doing flexible operations. This particular book has been authored by Mr. A.K. Sinha, and it is publicly available on the GTG India website. Last but not the least, the scalability potential, as I mentioned, CA in its report has also captured this based on our study. What we did was this was an exercise which was done with support from CA and other utilities. We looked at the host of units of 200 and 500 megawatts, looked at and we actually prioritize and benchmark based on their size, design, on the merit order dispatch, and the useful life that is remaining. And what was found out that close to 300 odd units can be made flexible. These are categorized into various buckets. So there are some units, some 80 odd units, which would require certain amount of efficiency retrofits. Some would require to be put in the bucket of flexible daily start, and of course, a large chunk of it should follow should do the load following. As I mentioned that while preparing the compensation mechanism, the load following happens to be the most economic way of adapting to flexible operations. So if I talk about numbers, the a 200 megawatt typically would essentially require rupees 50,000 per event of load following, whereas a 500 megawatt unit would be around some 2.5 to 3 lakhs per event of load following. If the units are required to start and stop on a daily basis, then for hot start, for warm start, and even for cold starts, the costs have been identified, and those are significantly higher than the load following cost that would be attributable. So, given the bandwagon of the flexible operations that have already been started, most of these and NTPC being the pioneer in taking it up, now most of the other states have also started realizing this. There have been a host of tenders that have been issued by state utilities, but still there is the pace at which the state utilities are adapting flexible operations is significantly slow. One of the primary reasons that we found out during the study was the absence of any compensation mechanism for low load operations. And this is where the units are essentially, the utilities are essentially resorting to reserve shutdown of units rather than following the load following principle. There is a host of potential opportunities for the OEMs also, as we found out during the study, because there is a lot of changes that would be required for in the instrumentation and control mechanisms or any other capital intensive retrofit that would be required for various identified units. And what we also found out was that there is no one specific solution for even for a 200 or a 500 megawatt unit. There are so many recommendations that came out from the study, both technical as well as operational. But what essentially was the conclusion is that there is no one fit for all solution for flexibilization. It essentially depends on the unit that is being taken up for the study. But having said that, the experience is that no major capital investments would be required for most of the units. Operational changes and upgrades of C&I system would unlock the substantial flexibility in the units. So that sums up for the brief presentation that we had on the pilot case study. Once again, thanks to all the stakeholders that were involved in the project. A big thanks to USAID and the GTG RISE team for all the support to making this a huge success. Thank you once again. Over to you, Monali.
Thank you so much, Anuj. Thank you so much for the excellent presentation and for highlighting the main learnings from the pilot and what needs to be looked at by the by the units which are looking at, flexibilizing their operation. So we have a short video which we would like to play. It kind of documents the journey of of the GTG RISE pilots in collaboration, which was undertaken in collaboration with NTPC, GSECL, as well as KPCL. So we will just play that, and then soon after that we will initiate our panel discussion. Can we please play the movie, please, the video?
Energy sustains life, and renewable energy empowers our sustenance. At present, India's installed renewable energy capacity has crossed 100 gigawatt, excluding large hydro, showcasing remarkable response to India's commitment to deploy 450 gigawatt renewable energy by 2030. As it accelerates the integration of huge amounts of renewable energy, unprecedented levels of clean energy would become available, strengthening the country's energy security and reducing its economy's carbon intensity. The share of renewable energy generation is expected to increase from 18% to 44% by 2029-30, while that of thermal is expected to reduce from 78% to 52%. But integration of renewable energy poses challenges to the grid stability. India's RE integration plans critically hinge on its coal-based power plants having the flexibility to tune their generation responsively to the variable RE generation as wind and solar energy vary with prevalent weather conditions. USAID's Greening the Grid Renewable Integration and Sustainable Energy, or GTG RISE initiative, addressed the issue by helping establish the Coal Flexibility Framework in India. Over the past 3 years, USAID, through this initiative, partnered with NTPC Limited and GSECL, the Gujarat state utility, to pilot flexible operations of coal units. The pilot included a study to assess the techno-economic feasibility of flexible operation at coal plants and developed a business case for policy and regulatory incentives for flexible operation.
The basic view of the study was to find out the cost of cycling, flexible operation, what would the costs involved, and what are the various problems that we are going to face during this cyclic operation. And this has given us a lot of data, and I can share with you out here. I think this is the first study that was done in India in power sector, in any of the stations, to actually identify and quantify the amount of cost that is going to be involved for the cyclic operation. Going forward, again with the help of USAID, we did another study at Mauda, our 500 megawatt unit. The basic aim of this study was to see if you can run the units at 40% technical minimum. And we were able to achieve this feat for a span of 2 hours. But both these two studies have given us a lot of valuable data, and we hope to use this data going forward for further flexibilization of our units.
The pilot supported NTPC and GSECL in achieving the lowest possible load points while still maintaining all other parameters under stable conditions. The large body of evidence it has generated is helping formulate a long-term flexibilization roadmap for India and in boosting integration of renewables.
The RE integration is must to have proper energy mix, and going forward this RE integration will further increase. So in the USAID study, it is observed that the flexibility and flexible operation of the thermal power stations, that has some cost. But in the CERC's regulations, there is compensation for low load operation and on various parameters of heat rate and specific oil consumption. But the same is not there in the Honorable GERC regulation. So the need of the hour is that such type of compensation should be incorporated in the regulation so that the utilities can operate the unit at low PLF, but at the same time they get compensation for the operational and maintenance problems they are facing.
Over 500 plant operators have been trained for flexible operation. and fleet-wide strategy developed for NTPC and GSECL. Technical interventions and operational changes have helped secure the success of this initiative.
So with the help of GTG RISE, we were able to run our units up to 55% and then 40% in systematic way. With the scientific manner they have provided us the guidelines, we followed those guidelines, and now with this help of GTG RISE project, our people now they are trained and they are running our units well below 55%. And I think we have escalated this procedure to all of our stations.
A crucial testimony to the pilot's success and part of its scalability efforts is the replication of the effort by Karnataka's state utility KPCL to make its coal plants more flexible. The low-load test runs are providing the building blocks for adoption of flexible operations. The US-India collaboration led to development of a business case for policy and regulatory changes to implement coal flexing at a larger scale in India.
Government of India, Minister of Power and our regulatory commission CRC, they have been doing a lot to push for this flexibilization. They have given the regulation for 55% technical minimum. They have also compensated the stations which are running on part load. So therefore, they are pushing the utilities to go for a part load running of their units to support the renewable integration, and they are also facilitating by giving the compensations. So seeing all these things, I think the government is moving in the right direction.
This strategic clean energy partnership between the United States and India captures their resolute commitment to a cleaner and sustainable environment, the two watchwords of the 21st century.
I do hope that you enjoyed the video. This journey would not have been possible without the support and the collaboration which we got from our pilot partners, NTPCA, GSCL, and KPCL. So many thanks, and we look forward to continuing our collaboration in the future as well. We have at least two of our pilot partners, NTPC as well as GSL, in our upcoming panel discussion, which will be now following up. Let me quickly introduce our moderator for this session, Dr. Pablo Coach, Dr. Pablo Hivia Coach. So Dr. Pablo is an energy analyst at the Renewable Integration and Secure Electricity Unit of the International Energy Agency, IEA, focusing on policy creation for integration of renewables and power market development in India. He has experience working on system flexibility, long-term energy scenario, and energy market development across projects globally with the focus on India and China. We're really delighted to have you, Pablo, for moderating this session, and I'll just pass it on to you, hand it over to you to take the discussion forward. Over to you.
Thank you very much, Monali, and thank you very much for inviting me to moderate this session. I think it's an extremely interesting topic and very good work that I've seen in the report of USAID. I hope that the video that was just showed is shared broadly so I can show it to some of my colleagues in Paris. And I would like to introduce some of our panelists. I am very glad to see that we have a very high quality panelists invited today. And I believe that the discussions will be able to point really at the main issues looking forward. One of our panelists is Mr. Vijay Mengani, who's the Chief Engineering at Central Electricity Regulatory Commission, CERC, and previously has worked at the Central Electricity Authority. Our second panelist is Mr. Ramesh Babu, the Director of Operations at NTPC, where he's been working on and responsible for the overall planning for safe, reliable, and efficient operation of the NTPC power generating stations. We also have in the panel Mr. Prasanna Kumar, who's the Managing Director of the Gujarat State Electricity Corporation, and he's previously served as the Executive Director, Corporate Field Management at NTPC. We have Mr. Bikash Chandra Malik, who's the Chief Engineer for the Thermal Project Renovation and Modernization at the Central Electricity Authority. And he's also leading an MOU with Japan on efficiency and environmental improvement of coal-fired power stations under the Indo-Japan Cooperation. And last but not least, we have Mr. Nikhil Kumar, who's the Managing Director and Principal for Energy Consulting and Digital Solutions in Intertech, who has broad expertise on most generation technologies, including technical and economical aspects and integration of different technologies on the grid. During this panel discussion, I will ask all panelists to please keep their cameras on. I will ask them some questions, and then there will be the possibility for the audience to ask some questions as well during the chat, which will be posed to specific panelists or all of them at the end of the session. So I would like to please start with Mr. Ramesh Babu, Director of Operations at NTPC, because I know that NTPC has been a pioneer in flexible operations, and there's been many initiatives like nitrogen blanketing or automatic generation control systems, condensate throttling, which have been really instrumental in shaping the way that utilities need to adopt flexible measures. And I'm thinking we have recently seen that India has surpassed the 100 gigawatt renewable energy installed capacity mark. What other measures is NTPC looking to address the growing requirements of flexibility in its units?
Good morning to all of you. Am I audible?
Yes, sir.
Okay. RE is going to increase exponentially within India. NTPC itself has planned for 60 gigawatt by 2032, and country is going to touch around 450 gigawatt. So therefore, the writing is on the wall that without flexible operation, the thermal units cannot survive in India. So we are one of the first pioneers in thinking about flexibility. How do you move about it? And as all of you know, we have been operating our units at 50% technical minimum. This has helped us in actually identifying the problems of flexible operation. We have done a lot of studies in flexible operation in consultation with the USAID and also other partners, and we were actually trying to quantify the costs involved in flexible operation, also the operational problems. We have done many initiatives like condensate throttling process, which we have done in Dadri Unit 6, where the condensate flow is throttled, where the extraction to the LPTs is throttled, and therefore it will give you more load in a short duration. Then we have the automatic generation control that we have implemented already in 63 units, that is around 28,000 megawatt. And it is being under implementation in another 27 gigawatt. So this has also helped us in actually achieving the flexible operation. The advanced process control, actually what we have noticed during this flexible operation is that there are large variations in the mainstream and reheated temperatures. The drum level fluctuations are there. So therefore the control part, the tuning of the control loops, that is very, very important. So we have started we have given contracts for the advanced process control both at Dadri and Simhadri to Siemens and Emerson's, and the work is going on. Around 90% work is complete. We are actually evaluating the results of this advanced process control. So therefore, we are working on two fronts to address the flexible operation. One is the hardware part of it. What are the elements that need to be changed in the boiler, in the turbine, like BFP, recirculation valve should be on a regulating mode instead of on and off this thing. And what are the loops tuning, the software part of it. So, and also we have been giving training to our operators, desk operators in these low load operations. Some of the problems that I have already noticed in low load operation is that we have seen a significant increase in the attachment failures of the boiler. That is because of the flexible operation. We have also seen a jump in the number of trippings due to flame failure, because whenever we are ramping down, there is a tendency of the flame failure. This is one issue that we have noticed, and we have adequately training our operators for this. There have been instead of the cracks in turbine casings because of the frequent low load operation. These are some of things that we have noticed, probably where we need to spend some money on all these things. The other important issue is the duct accumulation in the ash accumulation in the ducts because due to low load operation and the failure of the ducts. This is another important issue that we have noticed. So all this during low load operation, taking care of all this is going to cost us. And during our studies, we have seen that the cost involved could be, the capex could be around 30 to 50 crores per unit. And the operational cost that we have seen is around 24 paise per 200 megawatt, 26 paise, and 34 paise per around 500 megawatt. Based on the feedback that we get from Dadri and Simhadri Advanced Process Control, we would actually like to take this forward to all our units and see to that we actually have a good process control so that when you operate in a flexible mode, we do not have temperature excursions. And we have also identified some of the units too for a 40% technical minimum, just to see can they be run on a safe mode on a continuous basis. Yes, we did run at 40% for a short duration, but it was in a controlled environment. We would like to see that the operators can do it at will whenever it's required on 40%. See that actually they can be able to maintain the load on that. So this is the next step that we are doing. That select some units to run on 40%. And again, go for a more detailed scope of work and implement the advanced process control in all our stations. And I think one thing that would help is if all the stations within the country actually run on 50% technical minimum. I think many of the issues will be settled. There will be a lot of margins available for the renewable integration at the first step. Thank you.
Thank you very much, Mr. Ramesh Babu. That is extremely interesting, particularly looking at the two approaches between hardware and operation. I have a very quick follow-up question because I know that NTPC has been working in a number of studies with VGB and USAID as well as other agencies. And I was wondering if you could quickly share one of the, or maybe the key takeaway on how you can make plant operators more comfortable with operating flexibly their units.
As I said earlier, what we have seen during flexible operation from the plant operator point of view is whenever there is a ramping down, the unit outage on account of the eco-flow low for a supercritical unit or flame failures in a subcritical unit. So here, and being India having a lot of variation in coal, so this also plays an important role in the instability of the unit. So we have given extensive training to our operators on simulator how to deal with these situations. And the other issue is the process parameter variation that we have seen during the flexible operation. How do you minimize the process parameter variation? So that, as I said, we have already taken up with two of our stations at Dadri and Simhadri. And these will help us in actually identifying the broad scope of work and what elements need to be changed within the boiler or turbine configuration so that we actually have a good process control and there is no excursions. We did, actually I said, we did try at 40% minimum or technical minimum, and I think with this process control in place, this can be achieved in due time. For us, the key takeaway is we have been able to identify the various issues that are actually cropping up during flexible operation. That is the most important thing. Once we have identified the issues, we are taking actions. One is the operator training. The other is the hardware and the software part of replacement.
Super. Thank you very much, Mr. Ramesh Babu. Very interesting insights. I would like to ask a question to Mr. Prasanna Kumar, the Managing Director at Gujarat State Electricity Corporation. Because from the perspective of a state generating utility, I would like to hear your thoughts on what kind of enablers do you think are required or are essential for incentivizing the flexible operations of thermal power plants? And do you see a significant role of OEMs, of manufacturers, in supporting flexible operation?
At the outset, I thank USAID for giving me this opportunity. And for the country in general and for Gujarat in particular, flexible operation is the need of the hour, particularly in Gujarat, because of high integration of RE, particularly wind, almost 7,000 megawatt. The flexible operation of units is of utmost importance. And I thank USAID for giving the support. And because of USAID support, we operated our Ukai Unit 6 500 megawatt at 40% load, and we are continuously operating whenever it is required. And with the confidence we got from the Ukai operation, and in almost all the units we are operating at 40% whenever grid demands for it. So I thank USAID for giving the technical as well as moral support and training our operators also to maintain the 40% loads also as per grid requirement. Although our technical minimum is 68 to 75% as per the regulation, but we are maintaining 40% load as per the grid requirement, and it is a must for the power plants situated in Gujarat because of the frequent changes in the grid pattern. So it is a question between whether to shut down the unit and start it again, or to maintain it 40%. So with the support from USAID, now we are on most of the occasions we are maintaining 40% technical minimum and supporting the grid. And already we are planning for major R&M and turbine retrofitting in 4 units, 210 megawatt units. In all those units also we are incorporating this clause for technical upgradation for maintaining the technical minimum of 40%. The important problems which we are facing for maintaining the 40% technical minimum is, as already highlighted by Ramesh Babuji, is the quality of coal. When we are running the unit at 40%, maintaining all the parameters, suddenly if the coal quality is deteriorating, that is creating problem, and that is leading to flame instability and tripping. So to maintain the flexible operation in all the thermal power units across the country, the coal supplies, coal quality need to be improved and to be sustained at a particular level. Otherwise, it is very difficult, and it will improve. It will increase the number of trippings.
Thank you very much, Mr. Kumar. I think that is very insightful, and I think it's very important to highlight how your answer indicates how broad the issues are and how we need to look at the entire supply chain and not only think from a very high level. So thank you very much for your answer and your insights. I have a question prepared for Mr. Vijay Mengani, the Chief Engineering at the Central Electricity Regulatory Commission. Because
Can I add one more point?
Yes,
Can I
excuse
add one
me.
more point?
Of course, Mr. Kumar.
The main problem as on date which we are facing is that there is no because you are asking the next question to CERC. That's why I am trying to highlight this. Although CERC is having some compensation mechanism for part load up and technical minimum operation, the state regulators are not having any compensation mechanism. So that is creating a problem for operating unit at technical minimum of 40%. So my request is that there should be some
compensation mechanism in the state regulators also for encouraging this flexible operation and facilitating the RE integration. If required, in the RE tariff, these things are to be incorporated to compensate thermal power stations for operating at 40% technical minimum and allowing the RE integration. Thank you.
Thank you very much, Mr. Kumar. Appreciate it. Mr. Megani. Mr. Mengani.
Yeah, good morning.
I would like. Good morning. I have a couple of questions, but I think it would be also interesting to address the point from Mr. Kumar on the possibilities for state regulators to participate on the compensation mechanism for integration of renewable energy. But the question I had prepared for you is that I know that CRC has been actively supporting the creation of provisions that will enable market creation and participation by generators, which is an extremely important process for the development of the Indian power system. And I would like to know, from the perspective of our regulatory agency, what has been the response of conventional thermal generators on market participation?
Thank you, Pablo, for the question. And first thing I want to request you that the problem of flexibilization should not be only concentrated to see in the aspect of renewable integration. Once we realize the Indian market condition, one of the factor of flexibilization demand is coming from market itself. Due to competition and the less demand and the more capacity, flexibility requirement is also coming from market. So that's why the question answer is coming through a new dimension. That unless my power market participation by generator increases, flexibilization need will only be focused on the RE integration. Like Mr. Prasanna has said already, from the forum of regulator, from the Ministry of Power, we have issued instruction to the all regulators to incorporate 55% compensatory mechanism for RE, and most of them are agreeable to that. So far as the market participation in generation concerned, we have provided 2-3 different mechanisms in last 2 years. One is the real-time market, and another is the SCED with the unit commitment, which is we are proposing. Third, our ancillary service market has come. So multiple opportunities of last-minute portfolio optimization and correction is now available to the generator. So the flexibilization both from the demand side and generation side can be achieved through this. And I will give you a concrete example of this also. Before RTM, most of my regulatory or renewable ancillary service requirement was on upside. Last 2 years, we are facing now the issue of more downside requirement in the reserve requirement is coming. And when we see on the downside, I have sufficient portfolio of generator available for giving me down services. So in down services, I have no constraint to get the services. So before taking a regulatory decision to compensate for the flexibilization, we must realize that who should bear the cost of this flexibility investment. Whenever an investment proposal comes to the regulator, only 2 questions need to be answered. In how many years it to be recovered and from whom it to be recovered. So by creating a new regulatory regime through my ancillary services, new DSM mechanism, we are trying that all the flexibility services should be given by one system operator. So at present, what is happening, whenever we start charging individual customer, there is 2 types of problem that already I am facing operational issues due to wind, etc. Why you are burdening me through a different type of charge? So we do not want to burden an individual customer because all NTPC plants are some consumer group which are the part of that. We want the flexibility services should be availed by everybody and should be paid through a common fund. So that for that our ancillary service mechanism in new DSM will be designed toward that all the deviations which are being happened due to unintentional or through renewable should be compensated through a common pool. So the burden should not come to because already they are having complaint of balancing services by Gujarat and Tamil Nadu, etc. Another thing which is as a concern of an environmental person to me, that CRC is supporting every effort by the generator to fully compensate all environmental investment. But before taking the decision of investment in flexibilization, one question needs to be answered. I have been given a carbon portfolio. By making this flexibility investment, my carbon emissions, how it changes. Instead of avoiding a curtailment of 1%, whether I am increasing more carbon, or we should have been agreed, all should be agreed that 1% or 2% curtailment is feasible without increasing the more carbon. This is my benchmark. So it should not be that on the both side, customers should pay and even then the carbon emission is more. So this 1.5 degrees centigrade can be only compensated through less carbon emission. Another issue is the heat rate drop. Why we have not gone earlier from 55 to 40 in one step? India has started 3 steps. One is 55, another is 40, and third is the 25%. We have not gone for the 25 due to coal quality issue. But before moving from 55 to 40, I should have to see how much heat rate drop is happening between 50 to 40. This is where, if it did, this is very steep. The generator which is already facing scheduling problem, its scheduling problem should not increase. Like the investment cost given by you or other groups and the operational expenditure are differ from NTPC. If I am, even after investment, my schedule reduce more. So even I have to expend 25 paisa and that particular generator become less participative in MOD, then it will be a wasted investment. So both on the heat rate aspect, commercial aspect, we have to take a reasonable view. And the issue of compensation below 55, that is already on the table. We are actively considering that, but that will be not a mandatory. That will be given a commercial signal that how through either adopting the reserve shutdown or either going from up to 40%. The path should be chosen by the concerned generator and what will be the responsibility to serve the consumer at that time. That should be taken care. In our frequency characteristic structure, we have observed that why this type of flexibility demand comes suddenly. So in 2019-24, we have given one attribute of flexibility called ramp rate. To ramp rate, we have already incentivized through our tariff mechanism that if you not provide 1% ramp, I will penalize. If you given me better ramp, I will incentivize. Another is ramp rate contribution in the secondary reserve services we have already recognized and given them the compensatory mechanism. So one attribute has been already taken care of. Second attribute is MTL. MTL's role in providing the flexibility is not being quantified at present. Who should contribute and what? At present, if we see the scheduling, etc., every time there is a drop in load or increase in RE, most of the state generators are throwing the flexibility requirement on my NTPC plant. They expect that because they have the flexibility in scheduling, etc., let the flexibility burden go on to the NTPC. It is a common burden which should share equally. So we have to give that all my RE state and even non-RE state should have first moved from the at least 70% to 55%. And when the sufficient portfolio is ready, then we should be ready to invest in more flexibility because it is not a long, it is a medium-term investment. And from 2020 to 2030, my planning studies say around 2025, battery and gas may be a better flexibility resource. So this type of long-term investment decision should be taken care that how much time my investment will survive. So all the participants in the grid should equally share the technical requirements. So far the commercial burden is shared there. CRC is making regulations such that commercial burden should not come to the one individual customer or the customer who is not creating that type of requirement. So through a common poll we will try, and also in the DSM regulation we will make certain changes that the people should not hold the power at the last moment and try to unload that the real time, so down requirements coming to that. So this type of regulatory changes will reduce the individual generators requirement, but on the higher basis, on the system operator level, we are going for a unit commitment model also. That's why along with SCED, 1 or 2 unit can be placed in a unit commitment model. So at the last moment, some responsibility should not fall on my NTPC generator. And then the problem of sharing of that type of charges come, because in the last 2 years, lot of issue has been coming in RSDC also. In RSD also, even after losing the operational efficiency tariff, we are not able to compensate NTPC fully. So from the customer side also, better operational discipline we are trying to have. Thank you.
Thank you very much, Mr. Mengani, for that very, very interesting take. I would request you, if possible, to maintain your video on. And I would like to move on to Mr. Bikash Chandra Malik, the Chief Engineer at the Central Electricity Authority. And I have a question that is divided in two parts, one related to coal, one not related to coal. From the perspective of plants that are not coal power plants, I am very interested in hearing your opinion on which other technologies are shaping up in the country to meet the challenge of flexible operations. And then from the perspective of coal operation, what kind of policy level initiatives do you think we require to provide the right set of impetus to expedite the adoption of flexible operation for coal plants in India?
Thank you. First of all, I'd like to congratulate ASL for arranging this type of seminar or workshop for sensitize the this flexible operation. Actually, in CA we have studied in the conducted one study in the year of 2018, and after study we published a report considering the scenario of 175 gigawatt RE integration. That time we have seen that our coal fleet that installed capacity will be about 45%, and installed capacity of RE will be about 36%. And that time when all the other generation means hydro, nuclear, gas, if operates in business as usual, BAU mode, the stress on the thermal will be about means 84, about more than 80 gigawatt flexible power is needed from the thermal fleet. And that time it was calculated that about we have to run all the fleet at an average minimum technical limit about 26%, and which is very difficult, may not be feasible due to the high as content of Indian coal. So we have considered various steps like hydro, what that hydro is operating, that means whatever the pump storage in India is there, that can be utilized only for this balancing the grid only. And many state operated hydro plant is there. They are continuously running the hydro plant, and so we need the flexible power from hydro also. And we have also proposed that flexible cost means it's suitably compensated, means separate tariff for the flexible hydro power also to be implemented in India, so that we can have some flexible power during RE integration, and that reduce the stress on the thermal side. And that it is possible only if we some incentive is given, means per tariff like this, we can give some compensation or incentive to the hydro sector in state or central. And similarly, during when the grid sufficient in the peak time, when solar is means maximum is during the daytime, that time grid power should be cost should be less, so that state or other can absorb the power from grid, and by stopping their hydro during that time, and only they can participate during the balancing, means during the evening peak time. In this way, we can some way reduce the stress on the thermal sector. Similarly, we have also seen that net heat rate loss, deviation of the thermal units is less or smaller unit, that 210 and 500 megawatt units. So we have categorized some that units in three steps. What is the more flexible units? That is the 200 and 500 megawatt units, and the less flexible units 600 and above, and very less flexible units 800 or like this. We have also categorized the that very less. This is the 210 and 500 megawatt units can operate at 40% load, and 660 megawatt may operate at 45% load, minimum load. And similarly, others higher units 800 megawatt can operate at 50% load. So in this way, we can balance this this system, and we can have the required flexible power from the thermal fleet also. Also, we have seen that also started the conducting study, low load study, and implement some these measures to get to make them operate at 40% or 45% load. For that, that is a measures. Actually, it is the unit specific. So before implementation of any measures, we have to go for the low load study. Accordingly, we have started the study, conducted study about 8 units in India. We have already completed that study, and everywhere we have successfully achieved the target 40% load with ramp. Ramp rate is 1 to 3%. Somewhere we achieved 1% ramp rate per minute, and somewhere we also achieved the 3%. But we have seen that in India, considering the 175 gigawatt that RE integration, if all units participate in the 1% RAM rate, means they if have the capability of 1%, that is sufficient. So that is not issue. RAM, the flexible partition with low load is the issue. That is the coal issue is there. So our is the target is that we have to categorize the these units like low flexible, very flexible, or this type. And another one thing we also like to propose that what is the capacity, means what is the capex and opex is required to make them flexible, operate at 40% or 45%. Accordingly, we want to suggest that what is the compensation, means what is the tariff to be for the flexible power. So that thing also we are studying that if we give the sufficient margin, means including capex and opex plus profit, if we provide for the flexible thermal power, then they will, that utility will come forward for and participate in the flexible operation. So third thing is the battery storage. Actually, battery storage in the CA1 study, the optimal mix generation did in the year 2029-30, it has been suggested that about 30 gigawatt battery storage is required. Considering the thermal power plant will operate at 55% minimum load. What is the cost difference? We have seen that battery cost is almost 5 to 6 crore per megawatt, and for 30 gigawatt battery storage, it is about 1,50,000 crore that investment is required. Whereas if we lower the technical minimum of the thermal power plant from 55% to 40%, that 15%, in 2030 also it is seen that about 200 gigawatt thermal fleet will be synchronized in the grid. So 15% means about similar 30 gigawatt more capacity to absorb the RE is there. And average cost, we have seen that about 25 crore per units that is required to make them capable at 40% or 45% load. So that is required only about 15 or 18,000 crore to make them capable like thermal total fleet. Means if we want to this power, flexible power from the thermal sector, that is a different 15,000 crore and 1,50,000 crore for the battery. Similarly, other disadvantage for the battery storage is that lithium is not available in our country, so it is the imported. Second is the service life is only 10 years, and disposal is also there. So our target is that to minimum. It is the only minimum requirement. The last resort is the battery storage. Otherwise, we should focused on the flexible operation of thermal power plant and hydro flexible power. And third one is the we have the plenty of this site is there in India about in hydro. The pump storage, we can have the small pump storage with investment of 3 or 4 crore per megawatt. So that thing we also looking into it from the CIA Hydro aims. They are exploring the this thing, that pump storage, small pump storage in India. Thank you.
Thank you very much, Mr. Malik. I would like to move to Mr. Nikhil Kumar, that is joining us from the west coast of the United States. Thank you so much for enduring the time difference. And I know that the ambient conditions and the cold quality and the entire framework in a way is very different between the United States, between Europe and India. And I would like to see or hear a bit what key differences did you observe when you look at the recommendations for retrofits of thermal units in India compared to the things that you've seen in other places around the world. And taking advantage of your US experience, I would like to know if you have an opinion on which market mechanisms allowed coal generators in the United States to participate in grid balancing, and do you think these are adequate in regards to the discussion we had previously for the expenses that these operators may have to incur to enable flexible operation?
Thank you for having me over. And so let me first start with, there are differences in, there's no doubt there's differences in the coal quality between what we see in the US versus what we see in India. But, all the studies that we've done, for example, in Australia, there are certain plants in the US as well with lignite, and, coal quality it's not so much as the coal quality itself is bad, it's the variation in coal quality in India that actually impacts the operation. So essentially, that is a variable that you have to work around as far as flexible generation is concerned. The way that the coal quality variation impacts the operations in the Indian context is more towards maintaining flame stability. So especially when you're going down to at lower loads, I think the previous panelists were quite elaborate and very, very clear about what the constraints are. So there are certain retrofits that we mentioned, but let me just think about how we approach the problems. If you look at the US, Australia, Europe, a lot of the coal assets are much, much older. In India, some of the units that we went and saw, obviously Ramagundam has been operating for several years, but there are a lot of newer units that are operating in India. So that's one technical advantage that you have. So in terms of cycling the unit, in terms of fatigue life, you can sort of look at it from a portfolio standpoint and say, do I really need to operate this unit for 80 years or 60 years? Maybe I can consume fatigue life on this unit at a much more rapid rate. Yes, there will be cost for it. And so you don't need that long horizon. So that's just one thought that I wanted to share with everybody. So age of the units makes a big difference. But I think the things that we talked about were controls. I think that was quite clear from the previous panelists as well. So controls, automation. So several sites that we went to, there was a lot of manual intervention, when they're operating, starting up the unit or bringing them to lower loads. That is something that, we would recommend minimizing off. There's damper controls. We'd walk down some of the sites and you would see broken links. So, damper control would be something simple compared to, major overhauls of the units. Spray control. So we would see that when you are doing manual interventions at these sites, you would see overspraying, and that would cause other issues. You would have, so my point being, there's a lot of different things you can do. We did mention a few things about, low turn down burner upgrades. There are some sites in the US that have been successful. Now, are there equivalent examples in India with the coal quality variations? That's a challenge that needs to be met. But all in all, I think understanding the cost of flexible generation helps you identify which units are more capable or which units are more likely to be able to support flexible generation. I think both CERC, CA, and GSC, SEL, NTPC, everybody runs a portfolio, and you clearly understand that there is no value in having 100% of your units performing flexible generation. You need to identify which units are more capable of performing this type of operation, and then invest in those units. Again, obviously, you don't want all the burden to be on NTPC, but you generally want a wider set of units, but also identify which units are cheaper to do flexible generation on. In terms of the market mechanisms, it's great to hear all the market changes that India is supporting. Now, if you were to look at the US case, which is quite evident, is that if you look at just the last 5 or 6 years, natural gas is king in the US, right? So the price of natural gas is so much lower than coal. So no matter what market mechanism you might bring is not saving the coal generation purely on an economic basis. It's got nothing to do with economic or environmental policy. It's just the price of coal price of coal generation is higher than natural gas. So natural gas wins out. So even though, if you have flexible power plants, whether they be coal or gas, one, you're capable of, or you have the ability to participate in day-ahead markets or real-time markets, which oftentimes would give you a little bit more of a mechanism for revenue generation. So that obviously helps. The ability to ancillary service markets, so in California where we live, we have flexible ramping, cost mechanisms or revenue mechanisms within the market. So there are obviously the market mechanism exists. The other thing that we've seen in the US, and the one thing to be clear is that the US is not one big market. There's several separate markets, but a lot of utilities here are still vertically integrated. So it's not like there's always a market available here. But renegotiating power purchase agreements is another way that has been successful. So going back to the buyer of the power, where we have coal plants, 900 megawatt coal plants or 800 megawatt coal plants that have had to renegotiate their power purchase agreement because now their capacity factor or PLF has dropped from 80% capacity factor down to 40% capacity factor because of the support that they need to provide, not just to, I think it's a fair point, not just for renewables, but also the market changes and the natural gas that takes place for coal is, so how do you negotiate that power purchase agreement where you get compensated for the low load or the cost of the degradation on the equipment? So with that, I think I'll keep quiet, but it's a complex problem, especially when you look at it from a large portfolio such as India.
Thank you so much, Nikhil. It is indeed a large problem, and maybe that's why I find it so fascinating, and many of us are so dedicated to it. I would like to thank all of the panelists for their comments, for their ideas. I believe we've covered an extremely broad range of suggestions, and I am particularly happy that we've gone not focused only on the technical aspects, but we've been going a bit beyond, we've discussed aspects of market, we've discussed aspects of financial and contract flexibility in terms of the PPAs. Mr. Babu mentioned aspects of operation related to training. And I think that this really highlights that the right people at the right places are aware of the right issues. So once again, thank you very much. And I hope that we all together keep working ahead on the path of increased flexibility. And I will give the word back to you, Monali. Thank you so much for this opportunity.